We're going to start with mini eggs math, pattern number 1. In this activity, I'm going to be making a pattern with mini eggs. And then we're going to look at how to represent that pattern algebraically and how to model it with some kind of a graph or a diagram. Great. I'm not choosing these colors in any particular way. I'm just grabbing them out of the bowl here. So step 1. So these numbers on the bottom here indicate the steps in the pattern. Missing one here. Make sure I've got all the right numbers here. And another 3 here. Okay, so if you're someone who has done unit chat before, or your teacher has talked to you about subitization, you might already have thought about how you could count these objects. There's lots of different ways. You can arrange them in some kind of pattern of rows, which is called a matrix. So this is like that. You could also arrange them in groups of 5 as a way of counting. Counting in 5s and 2s is particularly easy for people because, well, my theory is, because our bodies are made up of groups of 5 and 2. So we're very familiar with that counting system. If you think about it, you've got 5 objects on each hand, and you've got 5 objects on each foot with your toes. So you're used to already from a very young age recognizing groups of 5, and then groups of 2 for obvious reasons, 2 eyes, 2 ears, etc. But you don't have to group them in groups of 5 and 2. You could group them in other chunks if you wish. Okay, I think I'm going to do it like this, just for ease of counting. There. So what do I see? First step, I have 4. Second step, I have 7. Third step, I have 10. Fourth step in this pattern, I've got 13. 5, 10 plus 3 is 13. Okay, so when you're given a patterning problem and you're being asked to find the rule for the pattern, the first strategy that I'm going to suggest that you try is to represent it using a table of values. So that's going to remove the distraction of the colors, for example. It's going to remove the distraction of the orientation or the position of those pieces, and it's just going to boil it down into how many in each step. So I'm going to put step number, and I'm going to put number of eggs. Now this table of values I'm going to orient horizontally. I could do it vertically, but for the purposes of this video, because of the window that I have available to me, I'm doing that horizontally. So 4 steps. I'm going to leave a little blank here in case I wanted to do a hypothesis or extension into a step further along in the rule. So in the first one, I had 4 mini eggs. The second one, 7. The third one had 10. The fourth one had 13. Okay. The next step in this process is to try and figure out what was the rule that I was using from one step to the next in order to know how many more eggs I needed to add, assuming that that's the kind of pattern that we're talking about. So if I assume that my initial starting place was a group of 4, then I can see that from the first step to the second step, I've added another 3 eggs from there. Let's see if that works if I continue here. So I've got another group of 4, the group of 3, and another group of 3. Well, that looks like it's working. I'll double check again. So only one step isn't enough to be certain. You have to use at least a couple of points to be sure. Okay, looks like, yeah, I found a pattern that would help me to predict. So I could see that starting with the first step, I had 4 eggs put down on the table, and then each step after that, I added another group of 3 to this pattern. So now I'm ready to write this as a rule. So I'll go ahead and call this a pattern rule. So in order to figure out how many eggs I would need to put down on the table for any step number, I need to know 2 different things. I need to know the step number, we'll call that n. Usually we use n to represent number because for obvious reasons the word number starts with n. And then what I would be trying to figure out is the number of eggs. So I'm going to use an E for eggs because eggs starts with E. Now, if it was a straight multiplication, 1 times 4 is 4, well, that works for the first one. But 2 times 4 is not 7, and 3 times 4 is not 10. So I know it's not a straight multiplication, so I've got something else going on here. So instead I'm going to look at it like this group of 4 that was added at the beginning as my starting group is a constant. So that's the second piece of information. And then the piece that is variable is the groups of 3. So in the first step of this pattern rule, I had my constant 4. In the second step, I had my constant 4 right here and 1 group of 3. The next step, I had my constant 4 and 2 groups of 3. Next step, I had same constant 4 and 3 groups of 3. So I can describe that this way. Whatever the step number is, I'm going to take 1 away from that. And that's going to tell me how many groups of 3 I'm going to be adding. Groups of 3 would be represented as a multiplication. Groups and multiplication are usually used interchangeably. Plus my constant of 4. So think of it this way. First step, I go 1 minus 1. So I've got 0 groups of 3. then I've got plus 4, which lands me at 4 eggs. Step 2. 2 minus 1 is 1. So 1 times 3, 3. That's this group right here, plus the 4 constant. Third step, 3 minus 1 is 2. So I've got 2 groups of 3, and that's what we've got here, plus the 4 constant. So step number minus 1 times 3 plus 4 gives me the number of eggs in any step. And if I want to simplify this a little bit more, I can replace the words step number here with that n, the variable n. And just to clean it up, I'm going to take the times 3 and I'm going to move it out to the front. It gets rid of that multiplication sign. There's still a multiplication in between the 3 and these brackets. It's just a little bit cleaner. And there's my pattern rule that describes this pattern of mini eggs.